Whew. Okay. Divide by -2. Wow. Wow. Oh, that might be me. Oh, no, it's not me.
Not me.
Anyway, m equals -5/2. Leave it like that. Okay. Now scroll your paper on down to number 6. Okay, and this is called a rational function. I want to remind you from your blue sheets. Back in the day when we did the blue sheets, I said rational functions might look like this or this. And this one is kind of in this style right here. Okay, and what we need to know is how to graph our asymptotes. So we have a vertical asymptote at x equals -2. And we have a horizontal asymptote at y equals -1. I'm going to grab my ruler. And I'm only going to count to 2. I don't think that Kermit the Frog could handle negatives if he's having trouble with anything past 4. I'm just saying. They might want to work on more positive numbers first before we are tackling the integers as a whole. Now, if you go on YouTube and watch that this weekend, and you watch further into the video, the count comes on and starts counting. It's a treat. Do you remember the count? Okay. Now, if you guys remember, back when we were graphing these in chapter 1, actually it was chapter 2, I told you to kind of ignore the A value because they're all the same shape. They're hyperbolas. But the thing you focus on is what kind of quadrant to put it in. Since it's negative, it goes in the top left and bottom right. And you don't really do anything with the 4. It's 4 times steeper, but it's so steep it doesn't even really affect it because it's already really, really steep. Okay, and we're going to write reflection across x-axis, vertically stretched by a factor of 4. Shift left 2. Shift down 1. Okay. And if you could please find the 5.1.2 resource page, that is what we're going to work on today. Today is more of what we did yesterday, but we're going to talk about 3 weird situations of inverses. So now we're in math 3, not math 2. So we need to take the information that we got from math 2, which was yesterday, basically, and talk about some weird things that happen. I'm going to use 3 different colors and a straight edge, just so you know. That is a wonky table. That's fine. Totally okay. Thought you were using a straight edge. Yeah, I wasn't going to use it for that, but okay. This is weird situation number 1. And it doesn't look weird at first. It looks all like, usual. It's just a line. And we're going to first write down the points off the line. So this point is -6, 0. This is where I messed up my counting, by the way, and what brought up the video. It wasn't this one, it was the one on the back, but it's fine. -4, 1, 0, 3. Are you guys see what I'm doing? 2, 4, 8, 7. Okay. So it doesn't look weird yet. It's totally fine. Just made my table. La di da di da. Okay, and now I'm going to do my inverse table, which is just the flip. So 0, -6, 1, -4, 3, 0, 4, 2, 7, 8. Zero, -6, 1, -4, 3, 0, 4, 2, 7, 8. Okay, so next question I have for you is, if you do know what Sesame Street is, do you also know what The Price is Right is? Yeah, it's an old-timey game show, so it's still going on. My favorite game on The Price is Right is called Plinko. Costco had a giant Plinko on sale this summer. Did anybody see the giant Plinko? This has nothing to do with the lesson. I just like Plinko. It's like this thing where you put like this disc in and then it like goes down and then you win the prize that it hits at the bottom. My second favorite game is the one where they do the yodeling song. And it like the little guy goes up the cliff and then you get if you guess too far off, then he falls off. What? I could. I think I already used all of my auditory licenses today though. Come on. I don't think that it'd be a good idea. Do it. I already had to scrap one video. Okay, how do you feel so far about this problem? Are you okay with the problem? So we just wrote down the points, switched them, graphed the other line. I checked my work to make sure it was reflected across the line y equals x. That's how I do my check. I'm going to do this every single time we draw an inverse graph. And okay, so now I'm like, okay, cool. I'm going to go into finding the equation of the inverse. This is where it gets a little weird. Also, here's another note. I have gotten to the point now where I'm unable to write the words for operations. I just can't do it. It's not going to happen anymore. So what that means is instead of writing multiply by 2, I'm going to put .2. And it'll get worse and worse as the chapter goes on, just so you know. Okay, anyway, so if I plug a number in here, let's just pretend I plug in 1. What would be the first thing I would do to it? Yeah, multiply it by 0.5. So notice my notation, times 0.5. That's about as best as I can do there. Okay, and then step 2 would be add 3. Okay, Mrs. Talbot, why did you switch from bullet points to numbered steps? I did it because of the dot for the times, because it looks like times times if I do that. And I'm too lazy to write out the words multiply by. So this was my idea. Okay, now we're going to undo the, oh, wrong pen. We're going to undo this first. And then undo that. And then we're going to talk about why that's just a bad plan. Does anybody already know why this is a bad plan? Okay, so first write y inverse equals, and then we always start with an x. I told you guys, we always have to start with an x because we have to have something to do our stuff to. But step 1 is subtract 3, and step 2 is divide by 0.5. And then you like, oh no, that is not how a final answer would look ever. This looks terrible. Okay, so this is why it's weird situation number 1. What is a better way to describe times 0.5? Steven?
Oh, 1/2.
True. Divide by 2 is what I was looking for. So what I'm telling you is lightly cross this out and amend your work to divide by 2 instead. And lightly cross this out and change that to times 2 instead. And lightly cross this out. Okay, so we're going to start over because that's fine, right? We can decide that our approach wasn't great. And we have x, and then the first thing we do is minus 3. And then times 2 on everything. And then distribute. Now there's slope-intercept form, and you can actually tell your line has a y-intercept of -6 and a slope of 2. Okay, so weird situation number 1. If you're finding yourself multiplying by a decimal, don't do that. Instead, make it divide by its reciprocal. Again, don't multiply by a decimal. Divide by its reciprocal. It'll make it so much easier for you in the end. Okay. Or you could just think to yourself, try to keep a whole numbers. Okay, so that's weird situation number 1. Weird situation number 2. Okay, totally fine so far. Not detecting any weirdness yet. Mrs. Talbot told me it was going to be weird, so, you know, on my toes over here. What is that sound? It's freaking me out. I'm not really picking up anything weird yet. I do notice that I think the inverse of a parabola is a sleeping parabola. Fascinating. Okay, so that part's all good. All right, so that must not be where the weirdness lies. Okay, so order of operations, parentheses first, then exponents. That's my symbol for square. It's just a little baby square. Then multiply. Then anything on the outside. We good so far? Okay. I wonder how many steps there are in this one. What step comes after one? What comes after two? What comes after three? Sorry, I've ruined your weekend now. All you're gonna hear. Okay, now that seems okay. Seems totally fine. You guys are like, all right, we made it pretty far. Don't see anything weird yet. Okay. All right, so we start with an X. Oh no. Snap. We start with an X plus 6. Divide by 3 on everything. Square root everything. Minus 2 from everything. Okay, Mrs. Talbot, I did the whole problem. You're a liar. You're a dirty, dirty liar. You told me there was going to be something weird, and there totally is not. You.
That's a square root function,
Yeah,
not a sleeping parabola.
nice. That is a square root function, which is only half of a sleeping parabola. Oh, snap. Okay, what's the thing that I tell you guys to do every time you square a root both sides of an equation? Plus or minus. So when you do these problems, when you have a square root as one of your steps, you need to remember to plus or minus. Okay, so this is technically not just square root. It's technically plus or minus square root. And this is technically not just this. It's technically plus or minus this. And technically, for the Stevens and Walters, this is not really one piece. It's really two separate pieces that we put together because otherwise it wouldn't be a function. So you kind of have to be like, oh, the plus is the top piece and the bottom's the minus. And that's why it works. But it only works if you do the plus and minus. Now, in pre-calc, if you pre-calc, you're not going to do the plus or minus. No, 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 it's worse. Just wait till you're excited about that. Now, in pre-calc, what's gonna happen is you're going to take your original parabola and you're going to restrict the domain to only half of it. And it's just gonna be the half of it that would correspond to the top half of the square root part. So your original problem, you'll just have half a parabola, which will inverse to the square root function. Which means you're going to have the right domain and range every time. Yeah, so we're kind of copping out a little bit here, but that's okay because we're in math 3. We're not freak out. Okay. All right, go to the back. We have weird situation number 3. Sure, right in the middle of my What comes after what? -5, -8. Yes. Oh, I know, it's weird. While you guys are talking, I'm writing points down like mad. This bit right here is where the song came out. I had this written as 4 or 5 and it was wrong because I didn't count to 4. Yeah. Ooh. What comes after what? Copy what? The Grinch? Trying to make the Grinch. No, no. Sorry, I was just having fun. Okay. Oh, sorry, I was having too much fun. Okay, so whoopsie. So now we're gonna find the inverse. But the problem is, what's the first thing that happens to x? Okay, but what about this x? Steven? Yeah, there's two X's. So you guys get to live in kind of like no solution land for a little while. Because we're not going to do inverses when there's two X's in math 3. You'll do them in pre-calc, but not math 3. So we're gonna say two X's. Nope. And the only thing you can do at this moment is just make the graph and flip the table. What? Oh yeah, you can make a Grinch, but I also thought it looked like a ladybug, and I also thought it looked like a person doing yoga in crisscross applesauce. What? Looks like Walter. Anyway, well, I've ruined it for you now. All you see is the Grinch, but okay. So okay, you guys, so we're doing 4 problems today. That was 2 of them. And then what? And then I combined these 2 problems into this one because it's going to ask us to do 2 different things with it. So I combined it into one problem. So we just have one more problem technically, but we have one more thing we need to do with it. And this is an example of weird situation number 2. So weird situation number 1 was don't multiply by decimals, divide by whole numbers. Weird situation number 2 was if you get a square root in one of your steps, you have to do a plus or minus, which you can tell is going to happen with this one. And then weird situation number 3 was the problem has 2 X's in it, which means I can't do it for now, but I'm going to do it next year. Okay, now this guy. This is a parabola. I hope that makes sense. Please, please, for all that is, let it make sense. And I'm going to do a table. Oops, I wanted to say f of x. I did that poorly. I put y and then I tried to fix it. Then, okay, anyway. Okay, f of x. Now, here is the big question. What is the vertex? What is the vertex when it looks weird like this? Walter knows.
I know.
You just said it. 0, 0. It's 0, 0. Okay, and so what you could do is rewrite it like this. You could take the x over 2 squared and move it to the front and make it the a value if you like that better for your brain. But do you see now where h is 0 and k is 0? Because there's nothing after the x in the parentheses and there's nothing after it after the parentheses themselves. Okay, so we're going to go 1, 2, -1, -2. Okay, what's -2 squared? 4 times 1/4? What? Trust yourself. I saw you wanted to say it. Okay, what's -1 squared? 1 times 1/4? 1/4. Okay. -2, 1. -1, 1/4. 0, 0. 1, 1/4. 2, 1. Yes, it's a wide parabola. Oh, wow. That looks a lot better than the one I did earlier today. Okay. Now, we're going to put it. Sleeping parabola. Great. I'm going to do this every time. Every time. Okay, graph check. We're still on number 17 though. We're not yet to number 18. Okay, now I'm gonna have you guys look at this one to make your steps. It'll be a lot better. So parentheses first, so divide by 2. You can see I was trying to avoid the multiply by a fraction deal here. So divide by 2, and step 2 is square. Okay, now what's the undoing of square? Plus or minus square root. And then times by 2. Okay, so F inverse of X is, okay, now I'm going to start to pull out the crystal ball here. The crystal ball is showing me that all of this business in these steps is going to go in the front of X. Square root goes in the front, plus or minus goes in the front, and times 2 goes in the front. So I'm going to put my X way over here. Okay, and then I'm going to put my plus or minus here, my 2 here, and my square root here. So that looks pretty. Okay. What? 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 No, that was all number 17. Yes. Okay, now we're on number 18, which is the last thing. And I have to show you something cool about how domain and range works with inverses. And then we're done. Okay. I have taken the liberty of getting my yellow sheet. This is not even, what am I saying? Blue sheets in stats are like formula pages of yellow sheets. I don't know. Okay, anyway, so a regular parabola, so the original parabola, the domain is all real numbers. And the range is y is greater than or equal to k. K was 0, so y is greater than or equal to 0. Which we should be able to get off of the picture anyway. Okay, but this is the cool thing about inverses. Just like you flip the table and flip the x and y, you can flip the domain and range because domain is x and range is y. So this guy is going to come up here and become x is greater than or equal to 0. And this guy's going to go down here and become all real numbers. And you don't have to think about it. You just flip them. No thoughts required. Save the brain.